Okay, I'd like to do another one here. This one's VV. So we have an identity to prove here that the square root of all this orange stuff is going to equal to plus or minus 2 tan theta. So how are we going to do that? Well, let's leave this side alone, and let's try to see if we can turn this orange and blue thing into plus or minus 2 tan theta. So first of all, let's just put this guy up here. And we're going to start with our 2 and just put him down there. Now we have cotangent squared of 90 minus theta. Cotangent 90 minus theta. Well, one thing that we need to remember are some of our cofunction identities. And I have written that incorrectly. We went 90 minus theta. So cofunction identities are called cofunction because the cotangent of 90 minus theta is equivalent to tangent of theta. Tangent of theta. Let me just give you another example. You could easily search for cofunction identities, and you will find that something like sine of 90 minus theta is going to be equal to that exact same thing. Sine 90 minus theta is equal to cosine of theta. So if you have the co-function, it's the co of 90 minus theta is going to equal to the not co of the angle itself. Or if you have cosine of theta, it's going to equal to sine, not the cosine, but the sine of 90 minus theta. Well, this is the one that we need to use here. So let's come back up here, and we have cotangent of 90 minus theta is going to be tangent of theta. So we just need to add the square then. We're going to have tangent squared theta. Now we have this. Now for this step, I'm just going to rewrite it, but I'm going to switch the location of these two to simplify things for us a little bit. I'm going to write 6 secant squared theta minus 6. We'll talk about what we're going to do with that in a minute. All divided by what? Now notice down here they both have 2's, and that's kind of noteworthy that they both have a 2. That would indicate to me that we can take a 2 out front and have something left inside of brackets here. So what are we going to have inside of those brackets? We are going to have minus 1 plus that 2 comes out front. We're going to have cosecant squared theta right there. Now on our formula sheet again, and you notice in a lot of these problems you've got to become pretty familiar with what you've got on your formula sheet. So if you take a look at your formula sheet, you're going to see that cosecant squared is equal to 1 minus cotangent. So we could write down here cosecant squared theta is equal to 1 plus cotangent squared theta. Well, look what we have up here. We have cosecant with a minus 1, so I can take this minus 1 and stick him over here, and that'll give me cosecant squared theta minus 1 equals cotangent squared. And that's really helpful because instead of writing this yellow stuff, I can just write cotangent. So before we get to that step, I suppose we should keep going here. Just put plus or minus 2 tan squared theta. So now we're going to get rid of this, and I shouldn't get rid of that just yet. Let's put here the square root of, and I'm going to deal with the denominator right now to begin with. So we're going to have a 2, and then instead of yellow, that yellow is the same as this, we're going to just write 2 cotangent. So down here in the denominator, 2 cotangent squared theta. So now let's get rid of this stuff here. That's not part of our problem. Let's just start working. So then that leaves us with the top. Let's deal with the top now. Well, we're going to have here 2 tan squared theta. Now, this stuff up here, I'm going to do pretty much the same thing with this as I did with what we had here. We'll notice that both of them are have both of them have 6's, so we can put plus 6, and then inside of the brackets, we're just factorizing that. Inside of the brackets, we're going to have secant squared theta minus 1. So now at this point, you should go and take a look at the same formula sheet we've been looking at. And on that formula sheet, you will see secant squared theta equals 1 plus tan squared theta. Well, same thing. Move the 1 over there. You'd have secant squared minus 1. And that's going to equal tangent squared theta. So secant squared minus 1 is equal to tangent squared theta. So right here, yellow is going to equal to tangent squared theta. So let's try to write this down again. And in the top, we're going to have 2 tan squared theta plus 6 times, instead of writing yellow, I'm going to write tan squared theta. And that's going to all be divided by 2 cotangent squared theta. And this is all still supposed to equal plus or minus 2 tan squared theta. Whoops, not what we wanted to do there. Alright. Okay, so moving down a little bit more here, we are going to see what can we do. Well, I see an 8 in the top there. I see that we're going to have the square root of 8 tan squared theta over 2 cotangent squared theta. Well, I see the 8 and the 2. We can turn them into 4's. So we're going to have 4 over, now, what are we going to do here? That tan's going to stay where he is. But what about this cotangent? What is cotangent the same as? Cotangent's the same as 1 over 10. So now I have one of these 3-layered fractions. And when I'm dealing with a 3-layered fraction, I'm going to flip the bottom guy. Let's not do that. I'm going to flip the bottom guy and multiply. So what I want to do right now before I get any further into this is just do plus or minus 2 tan squared theta. So now we're going to bring this whole problem up to here a little bit. And we are going to look and see what we have. We have the square root of 4. Now, when I flip this bottom guy up and multiply, I'm going to have 4 tan squared theta multiplied by this bottom piece flipped and multiplied. So when I flip and multiply it, I'm going to have tan squared theta. And that is looking like, to me, that's going to be the same as 4 tan to the 4th. 4 tan squared, not squared, 4 tan to the 4th theta. And that's going to equal plus or minus 2 tan squared theta from up here and from down there. Well, the square root of 4, square root of 4 is 2. And when we apply the square root, we need to put the plus or minus. And the square root of tan to the 4th, it's kind of like, what's the square root of x to the 4th? It's going to be x squared. So in a similar way, the square root of tan to the 4th is going to be tan squared theta. And now we can see we have here 2 tan squared theta. Pretty involved problem here, but definitely worth some time working through it, because there's a lot of good identities that were used in there, a lot of identities that you're going to need to be familiar with from the formula sheet. So I would encourage you to spend some time working through this and then let it sit for a few days and try it again.